Hey y'all, this is Mr. Alexander, and today I want to talk about IB Subtopics 6.1 and 6.2, which is functions, function notation, domain range, and linear models, finding equations, finding points in line, that sort of thing. So I'm just going to do as many questions as I can here before my 15 minutes is up. So we've got a graph of a function, v of t equals negative 3t plus 6. Write down the value of v of 1. So that's the same as asking what do you get when you plug in a 1 into that function. And negative 3 times 1 is negative 3 plus 6 is positive 3. And then what's v of 3? Well, that's just asking you to plug in a 3 into the equation for t. And that's negative 9 plus 6 is negative 3. It says the point m, 9 lies in the graph. Find the value of m. So they give us a y value, which is v of t. So I'm going to plug that in for y, and I'm just going to solve for t. So you subtract x, you get 3. Or sorry, subtract 6 and you get 3. Divide by negative 3, and you've got negative 1 equals t. Now you can confirm that on the calculator simply by going to y equals, typing in the function negative 3t plus 6. Go to the table at negative 1. The value of y is 9. Find the value of t for which v of t equals 0. Well, that's a y, and I can see on the graph that when y equals 0, t equals 2. Alright, last one. Find the set of values for t for which v of t is less than 0, meaning find all the values of y that are less than 0. And it's all these ones here, all of them where t is greater than 2. So 3, 4, 5, 6, 7, all of t's greater than 2 will give us a v of t less than 0. Number 2 here, consider the function f of x equals 0.5, 3 minus x. That's a linear function, of course. And if we're going to draw the graph of it, we just need 2 points, and we can pick any 2 points we want. And with those 2 points, I'm going to plot them, and then I'm just going to draw a straight line. Make sure you label your x and y axes before you draw them, of course. So the function is 0.5 times 3 minus x. And I'm just going to get any 2 points that seem nice to graph. So 1, 1 seems like an easy one. And also maybe if I go to 5, negative 1. That's 1, 2, 3, 4, 5, negative 1. At this point, you only need to connect those 2 points with a straight line and then draw some arrows signifying that it goes out forever. Find the point A where the graph meets the x-axis. So that's B. So this was A. B, find the point A where the function meets the x-axis. Well, that's just the x-intercept, and that happens right here at 3, 0. So A is 3, 0. Find the point B where it meets the y-axis. That's where x equals 0. So that would just be 0, 1.5. And then solve the equation f of x equals 2. Well, that's just saying y equals 2. So if I plug in a 2 for f of x, then I've got 0.5, 3 minus x. 2 ways to do this. Either solve it algebraically, which is what I'm going to do. I'm going to divide both sides by 0.5. 2 divided by 0.5 is 4. Equals 3 minus x. Subtract 3 to get negative 1 equals negative x, or 1 equals x. So that's one way to do it. The other way is to simply look at the table here, and we're looking for a y value of 2. And there it is right there at x equals negative 1, which you'll notice is not what I got. What did I screw up? Whoops. 4 minus 3 is positive 1. My bad. And then when you divide by negative 1, you get a negative 1 equals x. I apologize for that. So when x equals -1, y equals 2, which is the answer to part D. Alright, let's keep going here. Number 3 is a domain and range question. And whenever I'm thinking about domain and range, I'm thinking for domain, how far left, how far right. And for range, I'm thinking how low to how high. So the domain of this function, it goes left forever and right forever. So there's two ways to write that. You can either write -infinity to +infinity. Make sure they're round brackets, because round means it approaches but does not touch. Square bracket would mean that it does touch that point. This is approaching infinity, but it's never getting there. Alternatively, you could just write all real numbers, which is this symbol. It's the same thing. Your choice. The range is not all real numbers because it's going to, how low does it go? The lowest y value is 2, the highest is infinity. So it's going from 2 to infinity. Now it approaches infinity, does not touch it. It actually touches 2, so it's a square bracket there. For this function, the domain is not all real numbers. The domain is from -360 degrees to +360 degrees. And the range, the lowest value of y is -1.5, and the highest is +1.5. And it touches both of those points, so I'm going to use square brackets on that. Question 4. In a chemistry experiment, a liquid is heated and the temperature at different times is recorded. Here's a table. Draw a graph for this data. So make sure you label the x and the y. And I'm going to call this time. I'm going to call this temperature. And this is going to be in minutes. Oops. I think I did that exactly backwards. I should practice this before I do it. Time is in minutes, and temperature is in degrees Celsius. Okay, so I'm just going to put some scale on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go up by 50s here. So that's 100, that's 200, that's 300, 400, 500. So 1, 2, 3, and then 130 is just right about there. 5 and 2, 10. 7 and 2, 90. And then 9 and 4, 10. At this point, I just want to get a straight edge and draw in the straight line. And this thing goes out forever, so I'm drawing arrows on there. Although in this context it probably doesn't go out forever because there's probably nothing, there's no negative time, so let's just get rid of that. It goes out forever that way. Draw a graph for this data. What was the initial temperature of the liquid? Well, the initial temperature is going to be like right there, whatever it started at time equals 0. Now the easiest way to figure this out is to use a skill you already have. Go to Stat Edit, clear out the tables, type in the data 3, 5, 7, 9, and in list 2 we've got 130, 210, 290, and 410. We can get the equation for this data by doing StatCalc4. Just like we did earlier in the semester. And the equation is 46x minus 16. That's what it says right there. So if the equation, which is actually the answer to t, the linear model is t of x equals 46x minus 16. So that -16, that's the initial temperature of the liquid. So that would be -16 degrees Celsius. Alright, I've got a few minutes here. Let's go ahead and do number 5. I'm going to skip number 6. Different weights are suspended from a spring. The length of the spring with each weight is attached and recorded in the table. Plot a graph of these on your graphic display calculator. The easiest way to do that is go to Stat Edit again, type in the data. 125, 250, 375, 500, and then 30, 40, 50, 60. And then if you go to second y equals and turn on your plot 1, then you can go to zoom, I want to say 9 for stat, and you can see that this thing's a linear function. Okay? And while I'm at it, why don't I just go ahead and get the equation for this thing by doing StatCalc4. So it's 0.08x plus 20, which is the answer to part E, so I guess we're working a little bit backwards here. So L of x equals 0.08x plus 20. So the natural length of the spring is when x equals 0, so it would mean it's 20 centimeters. Just the y-intercept there. How many centimeters does the spring stretch when the weight is increased from 125 to 250 or to 375? Well, it goes up by 20 centimeters. And find the weight that will stretch the spring to a length of 48. So what I would do is I would say, okay, 48 equals 0.08x plus 20. And I'm just going to solve that by subtracting 20 and dividing by 0.08. 28 divided by 0.08 is 350, and that would be grams. Okay, and that looks like all the time I've got, so thank you for watching. Hope this was useful. We'll see you next time when we talk about quadratic models.